Hi guys, in this video we are going to discuss how to represent a phasor in polar form as well as in the Cartesian form, a rectangular form. So if you are new to this expert tutorial channel, please consider subscribing. Also, we have done many videos regarding electrical engineering basic fundamentals. If you like to watch them, I have given the link in the description so you can always watch them. So without wasting our time, let's move on further. So over here we are going to write what's meant by the polar form and what's meant by the Cartesian form. These are the regular terms. You can use it in, you will be using these two terms in many forms. Basically we will use them to represent any vectors also. So let's say this is the phasor, a phasor. We can tell it's going to be the magnitude of that phasor when we are considering any voltage or the current over here. This would be the RMS value of that. After that, we need to tell what's the phase angle between from the reference line. So this would be represented by the phase angle, and this would be the value of that RMS component. Let's say if there's the current general form, you can tell this is going to return the IRMS and the phase angle from the reference line. So this is known as polar form. When we are considering about the Cartesian form, it's going to be this little bit similar thing. We are going to separate this part into AX plus J into AY. What's meant by this? J is it's a complex number. We are going to represent it like this one, root of -1, which simply means it's a complex number over here. So what's meant by this AX and AY is, if we consider a triangle of which is having the length of this A, which is the RMS value of that component, and this is an angle, the phase angle. If we consider a triangle like this part, let's say this is a triangle, from this reference line is going to have the angle of phase angle of phi, and this value would be A, which simply means it's going to be RMS value. The AX value would be in this direction. This is going to be AX, and this direction is going to be AY. The important thing, we have used this J because to show the difference between these two directions. So we are going to use this J part, the complex number form, to show that they are in the 90 degrees direction. So if you consider this part, this value, which AX would be the mod of A, the RMS value, into the cos phi. Likewise, you can tell that AY is going to be mod of A sin phi. So this is a similar equation. From that, if you knew these points AX and AY, you can directly tell what's the point of this A. You can use the Pythagoras theorem over here. You'll be getting AX squared plus AY squared, and take a root of these two additions is going to return mod of A. So if you knew this one, you can directly tell this the RMS value of the component. Likewise, you can find the phase angle by using the trigonometric function. Let's say the tan phi would be equals to AY over AX. The main part is we can use either this part or this part. However, in the question they might ask to change this from the polar form to Cartesian form. Also, they can ask to change the component from Cartesian form to polar form. So you need to know what are they, and these are the two different methods to show that the phasor, what's the phasor like. So there are many methods, but here we are going to look at these two other basic and the main methods normally used by all So in the next video we are going to discuss further question from this part. I hope you can also watch them. I have given the link in the description. Thank you.